I'm about to educate you about the 16 by 1 multiplexer. So I'll take it from the meaning of multiplexer, what it is by 16 by 1 multiplexer, and then give the combination of the four selected lines. Also, I'll explain a little bit on it, and also talks more about the select of lines and how it's processed, how the output is going to be like, and also give how it works, which is in the logic operation also. And I'll give some example of a lifetime experience, then I'll draw the conclusion. So let's dive into it as I indicated earlier on. So I'm going to explain the meaning of a multiplexer, and then I'll explain furthermore. So one may ask, what is multiplexer? So it is a combination logic circuit designed to select one of many input signals and forward it to a signal output line. So this selection is called by a control signal, which is called a select lines. So basically, what's the meaning is, we are dealing with lines and also a logic circuit as well. So any line you select will give you the output, but then depending on what you click, when you click the correct ones, it will give you the output to be as green. The output will indicate to you that yes, whatever that you requested for has been granted to you. So assuming I clicked this port, which is the S3. I've clicked the S3, and now looking at the other ports, I need to go, and with the D's I need to go and search where it will be appropriate for me to tap so I could get everything. Now, so depending on the number I click, so this is 8. So you could realize after selecting the number S3 and then selecting D8, you could realize I've gotten the output. So this is the output. So that is it. So it depends on the number and the selection. That is the input and the output as well. So that is it. So what is 16 by 1 multiplexer now? The 16 input lines, which is the 60 input line, which starts from the D to 15, as you can see for instance on your screen, carry possible data inputs. So these are the possible data inputs. So as you can see, when I clicked the D8, that is the input. So the output has been given to me at the top. So as you can see, so when I click it again, you can see there's no output for me to see. But when I click on it again, that is the output. Now you realize, I should off it and see. Now you realize all the lines in D8, 4 lines were on. So you can see down here it is being connected to the S3, which is at the down. It is being connected to the S3. So you go and then look through it. So you realize among all the switch, all the D input lines, it's only D8 has the four lines being connected except from us to tap onto the D8 for it to be connected. So as I did that, you can see that yes, that's the output that has been given to us. So that is what they are saying, that it is the 16 input lines, which is the D to 15, carrying possible data input. So that's what I just explained earlier on. So we go to the next one, then four selected lines, which is the S0, the this one's the S0, the S1, S2, and S3. So they are used to select one of the 16 inputs. So as I demonstrated, as I selected the S3, I now need to look through and know where the next input for me to click on so I could have my output. So that was the D8, D8, that is it. So when I click D8, it gave me the output. So we move to the next one now, is one output line, which is the Y. The one output line, which is this Y, this very one, that is the output, which shows the selected input value. Yes, which shows the selected input value. So this is it. This is the result of the selected input value, and that is the output value also as well. So the combination of the four selected lines can represent 16 different binary values, which is the zeros to ones, allowing selection of any one of the 16 inputs. So as I explained earlier on, this one has just be a little explanation based on it. So the key component in the circuit diagram: input, which is the D0 to the D15, they are the data lines. Only one of them is selected at a time. So that is it. So it's only one. You can select the D within the D's, which are the inputs. It's only one that you can select. You cannot select two nor three because they won't react. So as you can see, I've selected another two in addition to the three, so you can see no reaction has been taken. But then it's only one that you can select. So select lines S0, S0 plus S3. Now these four lines decides which input to select. You will notice them at the bottom of the circuit. Okay, so what they basically means that, assuming S3 has been selected, let me go and switch this one off, the D8 off. So now S3 is being selected, we have to select S0. Now S0 has also been selected. So now we look through and see which are the possible inputs we need to switch on. Then we can take it forward. So now we have D9, which is a possible input. So as you can see, D9 has been imputed, and then the output result is being given to us. So you can see it has reacted by selecting the two the two the twos of the S0 and then S3, in addition to the D9 input, which has given us the output result. So that means we have selected the line S0 plus S3, which has given N, and this 9, which has given us the output result. So the NOT gate used to generate complemented signals for selections logic. Now an AND gate is also the 16 total. Yeah, the AND gate, that is the 16 total at the top there, which is the 15. So as you can see that I'm pointing, each input lines is connected to an AND gate one AND gate. Yes, an AND gate activates only when the selected line match the binary index of its corresponding input. So as you can see, as we selected, we corresponded to 8 binary input, because if it's assuming this one is off, the D9 is off, and I selected D8, you can see there's nothing showing, so that is not the correct binary input. But then the D9 is the correct binary input of the S0 plus the S3. So the OR gate, that output of all 16 AND gates are led to OR gate to produce the final signal output. So that is it. So that is what it is that has been explained here. So the OR gate AND gates to the OR gate produces the final output. So basically, the AND and the OR gates sum up to it to give you the output of the right binary that you've selected. So based on the value of S3, S2, S1, and S0, only one AND gate, only one AND gate gets fully activated, all inputs high, allowing the corresponding D1 input to pass. So that is it. So let me do a little bit demonstration with that, then you basically know what they are trying to say. So as I've selected 01 as S0, S1, S2, S3. So basically we have D5, D15 to be corresponded to it. So that is it. So that is the logic binary product that we need to select for it to bring the output of the result. So that is what you've seen. So we are going to clean it. So it's off. So let me give you a little bit example of if S3, S2, S1, S0 is equal to 0101, which is binary for 5. Then D5 is selected and routed to the output. So that is it. All other AND gates will output 0. Yes. So the output of the AND gates are then combined using OR gates. Since only one AND gate is higher at a time, the final output is simply the selected D. So that is what I say. So let me give a real life analogy here. So let me say a 16 max is likely to it's like a radio tuner. You have 16 radio stations, which is the D0 to D15, and by changing S0 to S3, you choose which station you want to hear through the speaker, which is the Y output. Yes. So that is it. So basically, during the conclusion and the summary, the system by one multiplexer simplifies large digital system, allowing you to handle multiple inputs with a single output. So multiple input with a single output. So that is the experiment that I did earlier on by selecting S0, S01, S02, S03, and then select D15, D15, which give you a single output, a single output, a single output. So summary of the table now, the elements and the description. So the inputs are the D's, the inputs, the inputs are the D0 to D15. They are the inputs, the data inputs. While select lines, the elements, select lines, description, which is the S0, the S0, S01, S0, S1, S2, and S3. They are the description of the select line, the select line. And then the end gate, which is the 16 total, one per input. The OR gate combines and output. And then the final output, which is the Y select inputs based on the S0 to S3. So thank you for another section of 16 by 1 multiplex.